Alright, so when I look at this number line right here, first of all, the open circles mean that it won't be equal to those values. Okay? So if you see an open circle, we know it's not equal to at all. If you see a closed circle, it'll be equal to. And so let's talk about this one right here. You see how I've got it shaded between -2 and 2? What we were just talking about the answer being between -2 and 2, the way we write that is -2 is less than x is less than 2. That's how we write it as far as the inequality is concerned, and then that's how the number line would work, because that means any number between it. Alright, this one out here, there's two parts to it. There's two parts shaded. So that means there's two parts to my answer. Okay? So this one would be x is less than -2, and then x is greater than +2. The next two are a little bit hard to see where the shading are. Let's say that this is the shaded part here, and let's say that this is the shaded part. When you see me do the problems, I'm going to not shade it quite so much with a line. I'm going to kind of shade it like an in-between line, just to try to make it more obvious where the shading is. So if it's your paper and you need to do that, you are welcome to do that. So this one right here is going to be a similar answer to this, except it is going to include them because of the closed circles. Okay, so the answer looks like that. And then this one is similar to this one. The only difference is that I have those closed circles. Still, there's two answers, but I put my little equals there because it includes that value as well. So if we think about the absolute value of x is less than 3, and we think about the values that we talked about earlier, ways to make that equation true. Well, I know 2 will work, 1 will work, 0 will work, -1, -2. All of those will work, but nothing bigger. So this answer is -3 is less than x is less than 3. It's between -3 and 3. You don't have to write this part necessarily, although it helps, because when you draw the number line then, basically what I'm going to look for on the number line is the values that are in your equation. And then I'm going to look to see if you put an open circle or a closed circle correctly. It's open because it's not equal. And then we have it shaded between because we know that those values can't go bigger. And again, I'm going to shade it like this. That way it's very obvious where the shading is supposed to be. Alright, so it looks like most of you were able to get these two right here, especially when you thought about what would make it true. So we know on our number line we would start at -4 and 4. It says greater than or equal to, so equal to, I know there's going to be closed circles. Okay, it says greater than, so start thinking, okay, what numbers can I plug in that would make it true? If I plug in 5, 6, 7, that would work. So that means that it will be shaded up here. If I plug in -5 or -6, that means that would be numbers down here. Now, after that, if you want to go back and write your answer as x is less than or equal to -4, or x is greater than or equal to 4, that's fine. We're going to be talking about both of those in just a minute because we actually have equations that are inequalities that we're going to solve. But in order to understand those, I think it's important for you to understand what the graph means and how to write the answer. Okay. Alright, next one says x is less than or equal to 6. Again, most of you, I think, were able to know that you start at -6 and 6. It's closed because of the equal. Okay, and if I think about values to make it true, if I plug in 7, 7 doesn't work because that's not less. -7 won't work because, again, that's not less because it'll be a +7 when I take the absolute value of it. But if I think about values between -6 and 6, like 0 or 1 or 2 or -2, all of those would be -6, so you have this part that's shaded. And then if you write your answer out, it would look like that. Again. So on the first one, absolute value of x is less than 0. Okay, just think about it. Okay, some of you started by going to the number line and putting 0 on it, and some of you even asked me, is there a negative 0? There's not. 0 is the only thing we can put on the number line. But just think about it. What does it mean if a number is less than 0? It means that the number would be negative. If a number is less than 0, then we're talking about negative numbers. Can an absolute value ever be less than 0? Can the absolute value ever be negative? Can't happen. And if I start plugging numbers in here, it's not going to work. So this is no solution. There's no shading. There's nothing to do. If you put an open circle at 0 and left it, that would be correct as well. But it is no solution because you can't have the absolute value being less than that. Okay, look at the next one. Absolute value of x is greater than or equal to negative 2. Okay, we can start by plugging in numbers and seeing what works. But before I do that, let's just think about it. If the absolute value, when I put in numbers and take the absolute value, I'm always going to get a positive, correct? Or 0. Is a positive always greater than or equal to negative 2? You can start by plugging in negative 2 and 2 if you want. It does say equal, so we do think that it will include those two values. But then just start figuring out numbers and to see what would be shaded. Like, if I plugged in 1, would 1 be greater than negative 2? Yes. What about negative 1? Yes. What about negative 5? Yes, because we're taking the absolute value of it. Absolute value of negative 5. What about 10? Every value that I pick is going to be greater because we're taking the absolute value of it, and the absolute value is always positive. And so what that means is we shade the whole entire thing. Or we say all real numbers. Alright, the very last one, and if it's cut out for you, it looks like this right here. Absolute value of x is less than or equal to negative 4. Again, think about it. I mean, we can go to the number line and put negative 4 and 4 on the number line and start working around what makes it true. But think about it. When you take the absolute value of something, is it ever going to be less than negative 4? It never can be, because we know that when we take the absolute value of it, it's always going to be positive. If you had started by making a number line and put negative 4 and 4 on it and then putting the equals, it actually wouldn't be correct because it's not even equal at negative 4 or 4. It's just a no solution problem as well. The only time that you really have to think about what the answer might be is when you have a 0 or negatives. And we had talked last week, anytime you had absolute value equal to a negative, how that didn't work anyway. So you just have to think about that when you're doing the absolute value to figure out, is it all real numbers or is it no solution? So in our patterns before, we found out whenever it says greater, that means we're going to have a greater than like this, the same, and then also a less than, like it's 2 parts. Whenever it says greater, there's going to be 2 parts outside of there, as long as there's not a negative on that number. And then when I graph that, remember to always put the smaller number first, because you're talking about a number line here. It's an open circle because it doesn't equal, and then it shades on the outside. And then for absolute value of x is less than 2, oh, that should be close, shouldn't it? Because it is equal, and I just messed up there. Sorry. Getting ahead of myself, I think. There we go. Alright, for number 2. It says less. It doesn't have equal, so I know there really are open circles on number 2. And in our patterns, when it was less, you put the x in between the two numbers. -2 to 2. And so we've got -2 and 2, we've got our open circle, and we'll shade in between. Now, number 3 and number 4 were the really tricky ones. Think about numbers that you can plug in for absolute value of x. Okay? I can plug in positive numbers, I can plug in negative numbers. All of them would make that equation true. The only tricky part is that this problem doesn't say equals. So I can't plug in a -3 and make it true, and I can't plug in a +3 and make it true. So what actually happens if I draw a number line on this one is we'll have an open circle at -3 and 3 because it doesn't equal those two values, but everywhere else it's going to work. And there's a couple ways you can write it, but somebody did say, can I write it all reals except -3 and 3? And you absolutely can. You could also write, very tricky, you could write -infinity to -3 with parentheses. We could do those interval notation. We'll talk about that more. You could say x is less than -3, x is greater than 3, and then x is between -3 and 3. You could do each part separately. There's a couple ways that can be written, but this is the probably easiest way. Alright, let's look at the last one. Absolute value of x is less than or equal to -1. Anytime that it says negative over here when the absolute value is by itself, we know that's the ones we really have to think about. But on this one, I don't even have to draw a number line on that one because I know that there's nothing I can plug in there that will make it true because the absolute value can never be negative. So it will never be less than a negative number. Alright, now we're to the equations. And this looks more like what we were doing last week whenever we did solve the equations. Okay? The only difference is we have a less and a greater. Okay? But we're going to do it very similar to how we did it last week. If the absolute value is not by itself, you've got to get the absolute value by itself first. And then you try to solve it. But we're going to use the patterns that we've sort of decided, especially with these two right here. So look at this first one. It says absolute value x plus 2 is less than or equal to 3. I know when I graph my answer that my answer is going to be between two values. And I know this because it has a less. That's my pattern. If I see a less, I know it's going to be between. So when I write out how to solve this equation, you're going to go ahead and start it off as if it's between two values. Okay? So I'm going to put -3 is less than or equal to x plus 2 is less than or equal to 3. That's how you're going to start it. Okay? I know it's going to be between two values because it's less, like this one here. I know it's going to be between two values. And so what we're going to do to solve it is we're going to get rid of the absolute value and then put it between the two values. So if we have a 3, we're going to put -3 and +3. If that would have been 10, I would put -10 and +10. Okay? Now, here's another thing that's a little different. We're going to solve for x. We're going to get x by itself. So it's kind of like solving that equation and then solving that equation. But we're going to do it all at once. Okay? I'm trying to get x by itself here in the middle. So I'm going to subtract 2 on both sides. Except there's 3 sides instead of 2. And when I do that, I get -5 is less than or equal to x is less than or equal to 1. After you write out what it is, then you go to the number line and you just sketch what that says. It says x is between -5 and 1. Close it off, shade it in the middle, and there's my answer. Alright, when it's less than, I know I write it between the values. When it's greater than, I know I'm going to have 2 parts to my answer. Okay, so that's how I'm going to start it. I'm going to start it with 2 parts. Okay? And I'm going to get rid of that absolute value. So I'm going to say that 2x plus 2 is greater than or equal to 10. So one equation is exactly the way it looks without the absolute value. And then the other one, we're going to switch it. Instead of greater than, we're going to say it's less than and change the sign. And think about it just a second. I know that that could be true because when I'm writing two parts and I'm trying to write something that has two answers, I'm going to have a greater than and a less than to make that true. And so that's how we solve it. Okay? And then you just solve each part. Subtract 2 on both sides. Divide by 2. Subtract 2 on both sides. Divide by 2. And then when we make our number line, think about the numbers. Put the smallest one first. We are going to include them because it says it has a equals. It says greater than or equal to 4, so I know I'll shade this part. It says less than or equal to negative 6, so I know I'll shade this part. So 6 is basically the same kind of problem, except you remember last week when we were solving absolute value equations and how we had to get the absolute value by itself first before we could solve it? Same thing has to happen here. See, there's an extra negative 2. I got to get rid of that negative 2 first before I can solve it. So what I'm going to do is I'm going to divide both sides by negative 2. Here's another tricky thing. You remember what happens with absolute values? I mean, not with absolute value. With greater or less when you divide by a negative? It could be, but that's not what I'm asking. You flip the sign. Anytime you divide or multiply by a negative, when you're solving an inequality, you have to flip the greater or the less than sign. Okay, that's a rule that you probably learned in Math 1. It's been a while, I'm sure. But basically, what that means is we have the absolute value of x is less than 40. Okay? I'll write that note out to the side. Divide or multiply by a negative. Switch the greater or less than sign. Now, even though we started with a greater, now to solve the problem, we look at where we are. We're at a less than now. It's a less than. I know it's going to be between something, so let's just write out what that's going to be. This is a 40, so it's going to be negative 40 is less than x is less than positive 40. And then when I make my number line, I'll put negative 40 and 40 on it. Open circles, shade between. We want to get rid of that 2 first because it's not inside the absolute value. You do it all at once, all at one time. And then we think about it because I see that negative. Okay, we're saying in the problem, I want the absolute value to be less than negative 3. I want any value that I plug in there when I take the absolute value to be less than negative 3. Can't happen because the absolute value will always be positive. So we're just going to say no solution. You don't even have to draw a number line. There's nothing that will work. Alright, so number 9. Again, the 4, you know where it says the plus 4? It's not in the absolute value, so I need to get rid of that plus 4 first. So I want to subtract 4 on both sides. Now I want to think about it. Okay, what values can I plug in that will give me values that are greater than or equal to negative 8? If you want to make a number line, you can. But when I take the absolute value of anything, is it ever not going to be greater than negative 8? It's always positive. So always greater than negative 8, right? And it's equal to, so we're good there. All real numbers. Anytime you have a negative on the other side after the absolute value by itself, just think about what you have that you have come up with to make sure that it's true. Alright, number 10. We're finally to a problem I think that you're going to be able to solve by yourself after we do a couple steps. I want to get that absolute value by itself first. So what do you think we need to do? Subtract 10. Let's do it. One more step. Divide by 3. Good. Okay, I want to see if you can solve that one. So because it's less, we're going to put it between two values. So 2x plus 5 is less than or equal to 9. On this side, it's the same inequality sign, so still less than or equal to, but then we change the sign. So that's what our first inequality would look like. We just put it between the positive and the negative, because we know that's what's going to happen with less than. And then we subtract 5 on both sides, so negative 14 is less than or equal to 2x, which is less than or equal to 4. Divide everything by 2, and we're dividing by a positive, so I don't need to change anything. And then when we graph our answer, close circles because it's equals, and shade in between. Okay, let's look at number 11. I need to get that absolute value by itself first. So I'm going to add 4 on both sides. Now we're at the point where we want to figure out if we write it in one part or two parts and then solve it. Again, it's a less, so it's very similar to how we did this one, how we wrote it between the values. Try that one. So I'm going to put negative 4 is less than 3 plus x is less than 4. Subtract our 3 on both sides. Negative 7 is less than x, which is less than 1. Open circles, and between because it's between. I think we have time for the last one, so we'll do it very quickly. Number 12. I need to get that absolute value by itself first. So what should I do first? Good. Subtract 14 on both sides. So when I do that, I get 6 times the absolute value is greater than 0. One more thing I need to do. Divide by 6. What happens when I divide by 6? Still 0. 0 divided by 0 is, 0 divided by something is still 0. So we're saying that the absolute value is greater than 0. This is one to think about. Remember, if it says greater than 0 or less than 0, or negatives, that's the ones that you need to think about before you just try to solve it. So think about numbers you can plug in there. And the fact that that will always be greater because absolute value is always positive. So the answer is, this one's not no solution because it says greater. So let's think about it. If I plug in 4, I'll get a negative number, absolute value will be positive. If I plug in 6, I get a negative number, absolute value to be positive. So still everything's good. If I plug in 3, three is the tricky one. What's going on at 3? Yeah. Alright, so let's go back. So we said 6 works, we said 5 works. 3? Because if I plug in 3, 3 minus 3 is 0, which is not greater. Okay, let's think about 2. 3 minus 2 is 1. Is 1 greater? Yes. What about negative 5? 3 minus negative 5. it'd be 8, which is greater than 0. So everything works except for 3. Okay? So it's like an open circle at 3, and then it's everything except that one. That was another tricky one. So if you want to write it in words, it's all real except x equals 3.